we discussed question 3 and question 4 for A-level Pure Mathematics paper 2 for May and June of year 2020. We are given two parametric equations for question 3. Both are exponential functions, and we need to find the equation of the tangent to the curve at the points for which t is 0. To find the equation of the tangent is always given by y minus y naught equals dy dx, x minus x naught. So from here, we need to find a fixed point on the curve x naught, y naught, and we need to find the slope dy dx at the point t equals 0. Then we just substitute all this into the general equation of the tangent to find the equation of the tangent to this curve. To find dy dx, we need to find dy dt. Y is given by 3e to the 2t plus 1. Then we differentiate this. The derivative of e to the 2t is e to the 2t, and then you need to differentiate the inner function, which is 2t, and that gives us a 2. 1 is a constant, you get a 0. And dy dt is 6e to the 2t. Do the same for dx dt. So we differentiate x with respect to t. E to the t has a derivative of e to the t minus 2. To differentiate e to the negative t, we have e to the negative t multiplied by negative 1, which is the derivative of negative t. And that results in e to the t plus 2e to the negative t. dy dx is dy dt over dx dt. We have 6e to the 2t over e to the t plus 2e to the negative t. At t equals 0, dy dx at t equals 0, we replace all the t's with 0. So we have 6e to the 0 over e to the 0 plus 2e to the 0. Anything to the 0 is 1. So e to the 0 is 1. We have 6 over 1 plus 2 here, which is 6 over 3, and that is a 2. So we know that dy dx has a value of 2, which we are going to use later. And we need to find the coordinates of a fixed point. So at t equals 0, you replace t with 0 into x. We have e to the 0 minus 2e to the 0, which is 1 minus 2. And we have negative 1. Y is 3e to the 0 plus 1. So that is 3 plus 1, which is 4. Then the coordinates of the fixed point is negative 1 and 4, which we need as well to find the equation of the tangent. Substitute these two into the equation of the tangent. We have y minus y naught is 4, and dy dx is 2, x minus x naught is negative 1. This results in 2 plus 1, y minus 4. So that y minus 4 is 2x plus 2. Bring the negative 4 over. Then we have y equals 2x plus 6 as the equation of the tangent. Question 4. You have the graphs of two modulus functions. Y is the modulus of 3x plus 2a, and you have the second graph, which is the modulus of 3x minus 2a. Now, a here is a positive constant. So it's just a positive number. And we need to sketch this graph on the same diagram. And also to give the coordinates of the points where each graph meets the x-axis. One easy way to sketch the graph of the modulus of a linear function is to sketch the graph of 3x plus 2a, and the part where the graph is below the x-axis is reflected upon the x-axis. That gives you the graph of the modulus function. So we consider the first case here, y equals modulus of 3x plus 2a. Then we consider the case where y is 3x plus 2a. We know that a is just a positive constant, just leave it as a. Then we need to find the x and y intercepts. So it's just a straight line. Once you have 2 points, you can draw a straight line. We let x to 0. When x is 0, y is 2a. So you have a point with coordinates 0 to a. That gives you the y-intercept. And then we can always let y to be 0. When y is 0, 3x plus 2a is 0. Then x here is negative 2 over 3a. So we have a second point, negative 2 over 3a and 0. That gives you the x-intercept of the first graph. So let's just draw the xy axis first for the graph. These are modulus functions. They don't go below the x-axis. So let's look at this. The x-axis and the y-axis here. And all these are in terms of a, the coordinates. So instead of using 1, 2, 3, 4 as your check mark, you can have a, 2a, 3a. So this will be negative a, negative 2a, negative 3a. Then that gives you a, 2a, 3a, 4a. Okay, now for this case here, for this graph that we have 0 and 2a, so that is 1 point. And negative 2 over 3a and 0, that is the second point. Then the graph that we have should go all the way up and down for this case. But we are looking at the case where any line, any part of the graph that is below the x-axis must be reflected upon the x-axis. So this part must go up towards the positive x-axis. What we can do is we can actually shorten this line all the way here, and then you draw a graph like that. So you must have a V-shaped graph, and so you have the V-shaped graph with the same slope, and that would give you the graph of y equals to the modulus of 3x plus 2a. Now consider the second graph, y equals to modulus of 3x minus 4a. So for this case, we are going to consider y equals 3x minus 4a. We want to find the x and y intercepts, and after that, whichever part of the graph that is below the x-axis will be reflected upon the x-axis, so that you can get the graph of the modulus function. We let x to 0. When x is 0, y is negative 4a. Now, y should never be negative, but don't worry about this first. So this is 0, negative 4a. We just need this to sketch the graph. And when y is 0, we have x. When y is 0, let's see, 3x minus 4a is set to 0, then x is 4 over 3a. The x-intercept would be 4 over 3a and 0. 4 over 3a and 0 is here, and we have negative 4a, but the graph must be reflected upon the x-axis. So we know that the graph goes down like that. So we should have a graph that goes down like that. And these two lines must be parallel. Look at this. Y equals 3x plus 2a and 3x minus 4a. The slopes are the same, which is 3. So these two lines must be parallel, that it should intersect the y-axis at negative 4a, but we want to reflect it upon the x-axis. So we are going to shorten this, and then the graph will intersect 4a here. So this part here, instead of negative 4a, we are going to have 0 and 4a as the y-intercept. And this blue graph is the modulus of 3x minus 4a. So the y-intercept that we have is 0, 4a, and the x-intercept is 4/3 a and 0. That gives you the x and y-intercept for the graph. Part B, we need to find the coordinates of the points of intersection of the two graphs. Now let's look at the point of intersection of the two graphs here. So for this case, you have the point of intersection. This will give you the point of intersection. This is the part of the graph where it has equation. This part of the graph has equation y equals 3x plus 2a. It is the positive part of the modulus function. And for the second part of the graph that we have here, this part of the graph, that graph has equation y equals to the negative of 3x minus 4a. This is the negative part that has been reflected. It was, if you consider 3x minus 4a, it was supposed to be below the x-axis. When we reflect it, we add a negative here. To find the point of intersection of these two graphs, we just equate them. So we set 3x plus 2a equals the negative of 3x minus 4a. So that 3x plus 2a is negative 3x plus 4a. Rearrange this, and we have 6x equals 2a. Dividing throughout by 6, x is 1/3 a. So you have x equals 1/3 a, and we need to find the y coordinate. We just substitute into this part. Y is 3x, x is 1/3 a plus 2a. So that becomes a 1, and we have 3a. Then the point of intersection has coordinate 1/3 a and 3a. This point of intersection has x coordinates 1/3 a. For part C, we need to deduce the solution of the inequality. We need this graph, modulus of 3x plus 2a, to be below the graph of the modulus of 3x minus 4a. Look at the point of intersection. So from the point of intersection to the left of x equals 1/3 a, we see that this graph, which is the modulus of 3x plus 2a, it is below the graph of the modulus of 3x minus 4a. So the solution to this inequality is x less than a over 3.